So here's a specific form of a production function. Q is a function. It's going to be equal to L raised to some exponent times K raised to some exponents. This is actually called the Cobb-Douglas production function, and it's very useful not only because it will exhibit diminishing marginal returns to the variable input, as we will prove in a second, but also because it's very similar to the utility function we have been using up to this point. Remember, utility was a function of x, y, raised to some exponents. This is essentially the same function, it's just that now it has different variables. So that you're not going to have to learn any new techniques to deal with this function because you've seen it already in utility theory. And now we're going to use it for production theory. But more importantly, as we will prove, it's also very useful because it represents those kind of characteristic of production that we talked about before, particularly the fact that the variable input will exhibit diminishing marginal returns. Now, in order to make the calculations easier for you to deal with this equation, now let's assume that both a and b in this case are equal to 0.5. It's a really easy form of the equation. So let's say that this is going to be equal to 1/2. All right? So what I want you to do now is to calculate, let's assume that you know how much output you're going to produce. It's going to be 50 units of output. I want you to calculate the values of labor if you know the capital is going to be equal to 20, 50, 100, and 125. So what I want you to do is to calculate the values of labor for these values of capital given this production function and for an output of 50 units. And this, playing around with the equation, it will help you quite a bit doing these calculations to understanding this equation better. So I'm going to stop here, I'm going to let you do those calculations, and you can see the answers and the rest of the discussion in the next video.